What happens when you strip Kubernetes down to its core, remove etcd, drop authentication, skip containers entirely, and try to rebuild it yourself in Go? In this episode of KubeFM, I got a chance to speak with Festus Owumi, who's an engineer at Plexi AI, and he decided to do exactly that. He built what he calls a light version of Kubernetes to understand the control plane from first principles, how the API server handles concurrency, how scheduling logic really works, and why the reconciliation loop is the heart of the entire system. If you've ever wanted to understand Kubernetes beyond the abstractions, this conversation breaks it down piece by piece. Clear, elegant, and surprisingly accessible for anyone working deep in the stack. This episode is sponsored by Stormforge by Cloudbolt. Automatically right-size your Kubernetes workloads with ML-powered optimization. Now, let's get into the episode with Festus. Festus, welcome to KubeFM. Which 3 emerging Kubernetes tools are you keeping an eye on?
Wow, I mean, that's an interesting question because I just actually saw a couple of tools that were released over the last days. And I think they're actually quite interesting to share. So I think the first one is Kubelet. So it's actually pretty incredibly fresh. It was just published, I think out of the Department of Electrical and Electronics of FPT, right? And Kubelet is an LLM powered multi-agent orchestration system that allows you to actually operate Kubernetes using natural language. So it's really cool, right? So imagine talking to the control plane and everything and creating pods, right? Then the second tool that I'm actually looking forward to is Kai by NVIDIA. So, I mean, it's a Kubernetes native scheduler and allows you to optimize your GPU use. So that's also something that I'm looking forward to. Then, I mean, the last one is also something that's also research paper. I'm really focused and I'm really interested in how we can use LLMs, right? In order to better how we operate Kubernetes infrastructure. So this is KubeGuard. So it's just LLM assisted Kubernetes security. But apart from doing statistical scanning, what it actually does is that it goes through your manifest and also looks at your real-time logs and tells you, okay, you can do least privilege configurations in this place. And then, so it just really just helps to harden your cluster security. So yeah, those are the 3 tools that I'm really looking forward to. Yeah.
Fantastic. And Festus, for people who don't know you, can you tell me more about what you do and where you work?
So I'm Festus. I work at Plexi AI. So what we do at Plexi AI is we're building machine learning agents to automate the entire life cycle of machine learning development. So from data to your tasks down to a model. So I usually work on scaling the ML platform there. So yeah, using natural language, you can just build a model from start to end. Yeah, really cool work.
And how did you get into cloud native? Tell me about your journey.
Yeah, I mean, I have a background in core application development. So writing Python backend, Golang backend, also writing front-end Flutter. So kind of your full stack, right, developer. But then at one point, I had to deploy serverless apps. I had to deploy an app to Cloud Run, right? And then I had to figure out how to do that. And that was actually how I got into cloud native. And then I think it was just when I did that, I was just really interested in wow, this seems cool, right? This seems what I want to do. And then I went down the rabbit hole of AWS, Azure, and GCP. Then we learned tools like Kubernetes, Helm. Yeah, so I guess just that first tool that I deployed, right, was the first step into cloud native for me. Yeah.
Okay. And the cloud native and Kubernetes ecosystem moves very quickly. How do you stay up to date? What resources work best for you?
Yeah, I think for one is Twitter, right? I believe that you can actually connect with many of the folks that are making waves in Kubernetes, many of the Kubernetes contributors, right? So Twitter is one because everybody loves to share knowledge, right, on Twitter. So it's just really just connect with everybody and then just consume knowledge. Another thing is YouTube. I think right now my algorithm is really cracked to suggest to me the next best videos. So watch a lot of KubeCon videos. And then I think I mean, just really just joining the ecosystem. There's a really big ecosystem. There are a lot of open source tools, right? I mentioned some tools that were recent, maybe a few days ago. So it's something to just get in, get into the open source system ecosystem, get into contributing. Yeah. That way you keep up with the environment. Yeah, keep up with the ecosystem. Yeah.
And if you could go back in time and share one career tip with your younger self, what would it be?
Yeah, I'd say you should actually post stuff online, right? So don't just do your work and then just stay in a rabbit hole or something. I think you should post stuff online and also like do really hard projects, right? I believe that that's the way you learn, right? You really do like hard projects, complex projects, they stretch you, and also share it online, and you never know who's going to like take a look at it. Yeah.
All right. Now, as part of our monthly content discovery, we found an article that you wrote titled Building Kubernetes, a Lite Version from Scratch and Go. So we want to dive into this topic a little bit more in detail. You decided to build your own version of Kubernetes from scratch in Go, which honestly, when we first saw this, seems like a pretty wild project. What inspired you to take on this challenge, and what did you hope to learn from it?
Yeah, I mean, I personally come from the school of thought that building things from scratch really helps you to like understand the idea behind the systems, and you can take that information to actually do like more complex things. For example, like the whole evolution of like LLMs was based on like the attention is all you need paper, right? And so like just like understanding things from scratch can actually help you to like do greater things, right, in the future. So I think that's just like the school of thought I come from. So I mean, I obviously just okay, I've been using Kubernetes for a while, and the thought just came, okay, why don't I just like see how it actually works underneath the hood? And then one thing after doing the project was I realized that it was actually more simple, right, than I thought, right, it was going to be. And it just made sense for me to just like share that with the world, because there's a kind of like steep learning curve that people have with Kubernetes. They're like, it's really hard, and I personally don't believe that. And I think that once you're able to like break it down to like first principles, right, you're able to see that, I mean, there's just like a basic mechanism that just controls how it works, and once you understand that, it simplifies your understanding of everything like layered on top. Yeah.
Before we get into too many of the technical details, can you help our listeners understand what Kubernetes actually does at its core? I ask this because you mentioned a reconciliation loop, so I want to know more about that.
Yeah, so Kubernetes is a container orchestration software, but at its core, what you should just think about it is that you have like your system, right? You have a desired state in which you want to get your system to, and you have the current state. And then what Kubernetes just does is takes that current state to the desired state. So an example that I can actually give to Jardine is just like a thermostat, right? You have a room in which like the temperature it's at a certain temperature, and then you crank it up and say, okay, I want it to go up or down to this temperature. And then the thermostat begins to work to just make sure that what you actually specified is actually what the room temperature gets to. And that's exactly like how Kubernetes like works internally. It's just really just me saying, I want this number of pods, this number of deployments. I schedule that, and then also Kubernetes is saying, okay, I see that you want this. Let me begin to like kick off like some events in order to actually make this come to pass. Yeah. So that's actually how it works.
And when you say you built a light version, what exactly did you strip away from the real Kubernetes to make this manageable? What are the key simplifications that you made?
Yeah. So like, when I said I built a light version, so what I did was that I really wanted to strip it down such that people are able to understand things from like first principle. But I didn't want to strip so much away such that like it's very different from like actually how Kubernetes works. So first thing that I did was that I removed etcd. So etcd is like the distributed key value store in Kubernetes, right? And then replace that with like an in-memory store. And this was because of like there's a whole lot of things that happens on the etcd distribute, because like it's a distributed key value store, and so there's like distributed consensus mechanisms that happen. It needs to also be like highly available. But like I didn't want I wanted people to be able to run the project on their local laptop without having to like think of all that. So that's why I use like the in-memory store. Another thing is also like persistence, right? The in-memory store is not persistent. Like, I mean, if you like close the terminal, the data is gone, right? But the actual etcd is actually like persistent. So yeah, I just stripped that down in terms of like etcd. And then the next thing that I also did was that I skipped out containers. So there was no containers. There was not. I mean, what we just actually had was like state login, right? That's actually what we had. So this was just because like we didn't have to deal with like container runtimes, looking at pulling the image and all of that, and just so that you can understand, okay, what is the cycle in which the pod actually goes. Yeah, so that's that. And then other thing I actually did was that I removed everything as regards like authentication, service discovery, RBAC, right? So all of that. So it's just pretty much simple. Like you can just literally deploy pod. I mean, ideally, right, you have to like go through like permissions in order to like deploy pods and everything, but no permissions necessary, just so that you understand it. And then the API server in Kubernetes. So instead of using watches and stream, so what I do is that the API server the components just pull the API server. So instead of using like watches and stream. And yeah, the last simplification that I did was that the only resource definition that you can actually like do is the pod, right? So you can't do anything more complex like deployments, right, and all that, just so that we're able to kind of like understand like the life cycle of a pod as it actually goes through like the system. So yeah, that's what I did.
Now let's talk more about the architecture. Kubernetes has this control plane concept that manages everything. How did you approach building your own control plane components?
Yeah, so just like article, I mentioned differences between like the control plane and the data plane. So in the control plane, we have like the API server, and then we also have the control manager, we have the kube scheduler, and then we have etcd. On the data plane, we have the kubelet, which runs on the node, right? So we have like the controller plane, and then we have like the worker nodes, and then the kubelet actually runs like on every of the worker nodes. So one thing that I really tried, as I said earlier, is like I really wanted to be like something very different from like this. So you actually have like all of these components in the article and also in like the code. So I have like the API server, I have like the kube scheduler, I have the etcd, which is an in-memory, and then I also have like kubelet, which actually runs on the node. I think the only thing that was omitted is the control manager, because the control manager handles like a whole lot of sophisticated control mechanisms, like those for deployments, those for node health and jobs. And since we're focusing on like pods, right, so it just makes sense to like strip that out. But everything is entirely like the same. So the architecture is the same. The control plane, you have like your API server, your scheduler, you have etcd, and then on the data plane, you have like your kubelet that runs on your worker nodes. Yeah.
The API server is often called the heart of Kubernetes. What challenges did you face when implementing your own API server, and what surprised you about how it works?
Yeah, I mean, one thing that was actually really like surprising about like the API server was how we actually manage like risk conditions. So like risk conditions is like where you're trying to like put some more requests, right? And trying to like update like a Kubernetes resource concurrently. And then I mean how K8s actually manage that is that it uses this optimistic concurrency control where it looks at the resource version, right, of each of like your definition and tries to compare if this version has actually like appeared and kind of like nullifies the other version just to prevent like risk controls. But then this just led me to just understand why in terms of an architecture Kubernetes had like the API server as like the gateway to etcd, because I was like, okay, I see that before you can access etcd you have to go through the API server. And but like when I begin to like go deeper, I began to understand why. Because for example, let's say a scenario if like the API, every other person could actually access etcd directly. Maybe the kubelet could submit information to etcd and other components, right? What's going to happen is that there's going to be a whole duplication of like logic. I mentioned like risk condition. One thing that the API server does is also validation. So it validates like the resources that you're putting in, right, to be ensured that okay, you're actually doing the right thing. And if we have like all of these things scattered about like all these different components, we're gonna have like duplication of logic. So it really makes sense to just have like the API server being that gate layer down to etcd. And then what this just does is that we are very sure that the API server is that central source of truth for us to actually get information, right, from etcd. So I think what surprised me about how it just works is like how it's able to kind of like manage all these complexities in one place, right? And how it's able to kind of like manage risk conditions and be like that single source, right, of truth, getting information from etcd down to like people that need those information or other components that need those information.
One of the most interesting parts of Kubernetes is a scheduler. It decides which containers run where. How did you approach building a scheduler, and what did you learn about how scheduling actually works?
Yeah, so for my Kubernetes Lite version, I'm actually looking like how the scheduler works, and it actually works via like a complicated like algorithm. But like for my article, I specifically focus on like a round robin approach. So this is what so I do like what the Kubernetes scheduler does, right, is that it says okay, there's a pod that needs to be assigned, right, to a node, and then it just decides how can I assign this pod to this node. What I did was a round robin approach where I have like a list of my nodes, right, that I want to assign the pod to, and then I assigned them in order. So I assigned to node A now, then node B, then node C, right, just in that order. But then in terms of like actually how it works, it's actually quite interesting and like more complex, right? There are a whole lot of things that actually go into the scheduling process than maybe like the round robin approach. Like for example, one thing that we didn't consider in the article is like, let's say, does this pod when this pod wants to get deployed on this node, does the node have the certain memory requirements or CPU requirements that actually needs this to be deployed? That's something like the actual scheduler actually looks into. So we have things like node affinity, pod affinity, for example. Some pods could say you could say that, okay, I want this pod to only be deployed on like some certain nodes, right? Or you could say that I don't want this pod to be deployed on like also on certain nodes, right? And they also like things to actually look into where you actually don't want this pod, right, on this node, and then policies. And yeah, so what just actually happens is that the scheduler actually looks through like all of these things that you define and that use that to like decide how do I actually want to deploy this, right, on a specific node. But one thing I actually realized when actually looking through is that there are actually times when after he has like done the scoring models based on like policies, affinities, node affinity, pod affinity, and taints, what happens is that you get to a time where you have like two candidate notes that kind of like come up, right? They meet all the criteria. And what happens is that he actually uses a round robin approach so that he's able to like distributes the load across like those two nodes. And so I mean, me using a round robin approach wasn't out of place because it's like what the last layer, right, that's actually used in Kubernetes to actually decide where or how a pod gets scheduled on nodes. Yeah.
The kubelet is what actually runs on each node and manages containers. Since you're not running real containers, how did you simulate this, and what insights did you gain about what the kubelet actually does?
Yeah, so I mean, since I'm not simulating this, so what I did was, or since I'm not actually using the container runtime, right? What I'm actually doing is I'm logging states. So typically you have like your life cycle of running, terminated, and deleted, right? So I'm just like logging this so that the user is able to understand what is actually happening. But then what this actually helped me to like appreciate is that the kubelet actually does a lot, right? So like when the kubelet receives like the pod spec from the API server, what it does is that, okay, we have this image, right? It uses the container runtime to see how we can like build the container, right, and then run the container of the image. And there are also things like liveness and readiness proofs that it has to kind of like look into, say, okay, now that I've run this container, right, I want to check, is it running successfully? Is there like any issue? And then I want to kind of like report back to the API server to let you know that there's actually an issue here. So like, I mean, there's a whole lot of like complexity involved, but by just showing you the state object, the state updates, which going back to like the reconciliation loop, like once like you decide what you want, right, there's just like a whole lot of events that just like get in to just make sure that you get what you want. So you're able to see that, okay, the pod is running, the pod is terminated, maybe like there's an issue, right, with pulling the image or something, right, and then you're able to see that the pod is actually deleted. So seeing those state updates helps you to understand like where the pods is in the life cycle, and just helps you to just understand like what the kubelet actually does and how it actually moves the pod through these different stages. Yeah.
You implemented an in-memory store instead of using etcd like real Kubernetes. What trade-offs did this involve, and what did it teach you about why Kubernetes uses a distributed key value store?
Yeah, I implemented a key in-memory key value store, and the reason why I did this is that firstly, like Kubernetes uses etcd, and one thing is that I wanted like users to be able to run this on their local machine with like without any external dependency. And I mean, etcd needs to be persistent. Like, of course, Kubernetes can use like an in-memory store, right? Because that would just mean that once, let's say, the node crashes, like, or the cluster crashes, like the data is gone. So the actual etcd uses persistence, right? That's like one trade-off that I made. I didn't want to have like an external persistence. I just wanted it to be like in memory. Then there also like some other things as regards like consensus, distributed consensus mechanisms. Like, for example, etcd is a distributed database, right? And then what actually happens is that there's a whole lot of, like, for example, there's a raft consensus algorithm that he actually used to decide the state of the data, in sense of maybe a node actually fails, right? We use like the raft consensus algorithm across like the nodes that are still active to decide, okay, this is actually the final state of the data at this point. And yeah, that would have just like been too complex, like in order to like deploy that. And since like the database was running in memory, it doesn't need to be so available, right? Also like distributed. So those are like kind of like the trade-offs in order to just like decide, okay, let me just do like in memory store, right? So that it's not too complex. You can easily set up. You don't have to like have an external dependency or external persistence, right? And yeah, you can just really just get the whole idea. But it still shows you that Kubernetes is a persistent layer at the back. So yeah, that's one benefit of that.
Now let's walk through the life cycle. When you create a pod in your system, what actually happens step by step? And what
Yeah.
was surprising about implementing this end-to-end flow?
Yeah. So, I mean, in the system, like in the article, there's a kubectl lite that I created. So it's just like a simple CLI tool. And then like this was actually quite important because when I was designing the entire system, I was thinking that okay, yeah, I'm gonna have my API server, I'm gonna have etcd, I'm also going to have like the kubelet. So I was like, okay, how would the clients kind of like talk to the API server in terms of like deploying pods? But because I wanted this to mirror like real life as much as possible, like we use kubectl, right, as like cloud developers, is like one of our favorite tools. So I decided to build out like my own kubectl lite. And so what happens is on the platform, once you use kubectl lite and you say you specify what you want to create a pod, right, in this namespace, right, given this image, what happens is that there is a client, there's an API client inside the kubectl lite that now talks to the API server and says, okay, I want to kind of create a pod, and then the API server receives that request, does the validation, and then marks the pod as pending. And then that's where we go into like the round robin approach, which we talked about from the scheduler. So what he just does is that he pulls the API server and says, okay, I'm looking for like pending pods that have not been scheduled. And then what he does is he gets those pods and then uses that round robin approach, which in real Kubernetes would be the complex algorithm that I talked about, and uses that to decide where this pod should actually go to. Then we also have the kubelet that is also running, right? That pulls the API server to say, okay, what are nodes that have been assigned, what are pods rather that have been assigned to my nodes? And then it takes that pod definition and then runs it on its node. So that's actually like the life cycle. So it goes from pending, the scheduler schedules it, right? Then the kubelet actually pulls that information and then marks it as running. And then the same thing to when you want to like delete the pod, right? It's marked as deleted on the API server, which is in etcd, and which feeds back to etcd. And then the kubelet is also pulling information, say, okay, this pod is deleted, so let me kind of like clean it up. So I think what was surprising about implementing this was that, just like what I said, like it just helped me appreciate when I just like do a single command on like kubectl or like kubectl lite, right? There's like a whole lot of things that just happen, and it's like that whole event driven mechanism, and it's just really nice and like beautiful to just see like the whole reconciliation loop come into play. Once I set this off, right, there's different systems that are running independently, but they are somehow just like performing in an orchestra, right, in order to like get what I actually want done. So yeah, it was just really like great seeing just how one change I did could just be like implemented and used by different systems in order to like get to that pod through the stages down to like a running stage. Yeah.
I know your curiosity doesn't just, start and stop with Kubernetes, because you also built a kubectl like CLI tool. How
Yes.
important was this for testing and understanding your system? And what challenges did building a CLI present?
Yeah, so this was very important for like testing the system. Like as I mentioned, I didn't want a case where people have to go and get like maybe Postman and then they're calling the API server directly. I felt like that wouldn't do justice to like how you actually integrate or how you actually work with like Kubernetes in production, right? Typically we use kubectl, right, and that's like get information. So I was just like, okay, wow, like why don't you just like build like CLI tools? And I think that when I was like building the CI tools from like a user experience perspective, right, it just led me to understand to appreciate like how kubectl is kind of like designed, in the sense that you really want to like design the UX such that it's almost like English, right? So it's almost like you're saying kubectl create, kubectl delete, kubectl, right? And so it's like English. So there's no too much learning that you have to learn. So if you look at like the kubectl mini, so you could just do kubectl create, and then you define what you want to create, and then you define the namespace. So it almost reads like English. You're just saying like, oh, okay, kubectl mini, I want to create a pod in this namespace, right? So I think getting that UX right is just good, just so that you don't really have to even always look up like the commands. Like once you have a mental model of like, okay, this is actually how like the UX actually works, using like namespace flags and images, it just makes it easier for like developers to kind of like working to. So I think it was just like from a UX perspective, I just wanted to like keep that user experience same as actually using kubectl, because the whole idea of the project is to just like have this simple system that is not so far from actually how Kubernetes is, and you can be able to kind of like draw parallels and understand things from first principle. Yeah.
What was the most challenging part of this entire project? Was there anything that seemed simple in theory but turned out to be surprisingly complex in practice?
Yeah, I think the most challenging part of this project was actually stripping down to, like the details, right? Because it was like, yeah, I looked at the actual Kubernetes, and yeah, it was like there were like a whole lot of components, a whole lot of like complicated scheduling, a whole lot of like things like the Kubelet running the container runtime on the node, everything. And for me, it was like, because the goal one like this one goal was, I really wanted to just communicate to everybody that, yeah, okay, when you actually strip Kubernetes down to its first principles, it's not complex, like it's not so complex, and once you understand this, it's like that perfect beginning layer where you can now begin to layer things on top of. So stripping down those details and then getting it such that it's not very different, right, from like how it was actually was like the most complex part. And then things that seem simple in theory but turned out to like be complex. I'll say like the scheduler. Like, I mean, like, yeah, you could just say, okay, it's just like it just schedules the pod, right? That's what you think. Like, you hear, okay, command. What the scheduler does is that it just decides where the pod should actually run. But then when I began to understand like the complex algorithms that actually go into it, like it has to think about node affinities, right? For like the pods, thinks about the taints. It has to think of like policies. He also has to think of like resource usage. Like, okay, what's this pod actually doing? What's the resources this pod is actually that has at this point, and can he actually take on this? What's the resources this node rather has at this point, and can you actually take this pod that is actually coming in? And yeah, so just that whole complexity was like really complex, but I was able to just like get it down to just a round robin approach, which I believed also like gave the ideas of like the different types of like algorithms that the scheduler actually use in deciding where the pod runs.
On the flip side, what aspects of Kubernetes turned out to be simpler or more elegant than you expected once you stripped away the production complexity?
Yeah, so it's like I mentioned earlier, is the reconciliation loop, right? It was really just like simple to be able to like understand Kubernetes from that viewpoint of like a reconciliation loop. Like typically, like when you hear about Kubernetes, like you're like it's an container orchestration management system. Is like, okay, that's like a mouthful of words. But then being able to like understand it, that it's just really you deciding or desiring a certain state of your system, and then there's a current state, and then Kubernetes actually doing all these events in actually to get you to that state. And yeah, so like once I was able to like strip it down and see that, okay, this is actually just like what it is, it just made sense to be able to understand that, okay, these are like, this is the flow, this is the life cycle of events that happen, this is what the kubelet does. Like, because like typically everybody knows the kubelet, but it made me understand like what the different components does. This is what the API server does, the kubelet does. And it also helped me, right, as a cloud developer to better debug, because it's like I can be able to now, I now know, like, okay, when a component has an issue, I know where to look, right? I know better where to look to say, okay, this is actually where the problem is. Yeah.
How did this project change your understanding of Kubernetes? And do you feel differently about using production Kubernetes now that you've built your own version?
Yes, I feel more confident, right, using Kubernetes, because I think it's just that whole thing of like, once you, if you have like the black box or something you don't understand, like it seems pretty ambiguous to you, but then once you've like uncovered it and you realize, oh, okay, so it's actually this simple, right? Then you're just like able to, you're just able to just like work with it better. You're able to understand things better. You can visualize the flow of information, the flow of events better, and that's like one thing that I wanted to communicate like with this article, the fact that once you strip out like all those complex details and stuff for like first principles, right, Kubernetes isn't as scary as you think. Yeah.
For someone listening who's interested in diving deeper into how Kubernetes works, what would you recommend? Should they try building their own version as well?
Yes, I think everybody should try building their own version of Kubernetes. Yeah, I feel like it's such a fun project that you just need to do to like understand. I feel like many of the tools that we use and that we actually respect, you should just really just like try building your own version. Like Git, try building your own Git, try building your own Redis, right? I mean, not just to just understand like the details. And like I said, like once you understand, right, it makes using those tools easier. And other things is that it gives you ideas, right? Because like a whole lot of engineering was involved in like building those tools, and there were like a whole lot of engineers that made like intelligent decisions and architectures, right? So you could use these ideas to apply them to like future problems that you actually have. So build your own Kubernetes from scratch. Another thing is, do not be scared to like go into the source code of like Kubernetes or any other tools that you actually use. I mean, the truth is like it was written by humans, right? And yeah, so don't be scared. And I think that rather than just like overwhelm yourself with like the whole complexity, start by asking, how can I like strip this down to like first principles, and then begin to like build up from that. And then you see that as long as you're able to like strip things down to first principles and build up from that, you're able to like build understanding of like really complex systems.
Looking back on this project, what's your biggest takeaway? And what would you want other developers to understand about the tools we use every day?
Yeah, my biggest takeaway is that the tools that we have today, like the really big tools, the complex tools, they're really built on like simple like concepts, right? And it's just like applying this layer of like complexity on top of them. So I think that we should not really like see it as, oh, like these tools are like really like alien technology and that, and like because that just gives us this fear to like contribute, right? Or to like take a look. Like especially with like contribution, people are like, oh, where do I start, right? But like the fact is like there are many tools that has like open issues, simple issues. I think it's trying to like take the whole complexity at once, right? But then once you just like start with the basics and then just like build it up, right? Then you'll be able to kind of like, do you get do really nice things. The tools we build, the tools we use every day were built like developers by like us, right? So, and it's also written in like English, right? And so I think that is just to just like start from first principles and also try out building your own version, right? It doesn't have to be an exact replica. Strip out the details, understand it, and then begin to like add layers of like complexity on top of it. Yeah.
Festus, what's next for you? What can we expect?
Yeah, I mean, I have like quite a few from scratch articles coming.
I'm shocked.
Demystifying some, I mean, complex concepts. So yeah, expect quite some few from scratch articles coming up for me in the future. Yeah.
Very good. And if people want to get in touch with you, maybe to work on a project together, what's the best way to do that?
Yeah, I'm Owumi Festus on LinkedIn. That's OWUMIFESTUS. I'm also at _ infinity. That's ENFINITY on Twitter. And yeah, my GitHub is also like available on the article. So I mean, I think that I'm also like, you can also like raise issues and also add PRs like to like the project, like in the article. I think one thing that would just be good is to be able to like have this as like first principle layer and then begin to like extend some parts just like build on that understanding. So maybe like we could see how we could implement like more complex scheduling in the scheduler, right? Or more complex validation in the API server. So yeah, feel free to contribute. Yeah.
Awesome. Well, look forward to seeing all the cool stuff you're going to be doing in the future. Thanks so much for sharing your time and knowledge with us today. Take care.
Have a great day. Yeah.
Cheers.